4, 5, and 6, same kind of thing. I'm solving trigonometric equations. These ones, I'm going to leave them between the intervals 0 and 2 pi, so I won't have to have that weird k pi stuff at the end. Still having that fraction or even a whole number in there with my x, but solving them like I did on the previous ones. Again, I want to have my table handy so I can look up my values as I go, so make sure you have your table. And so if I go back here to number 4, I'm going to start my solving and saying that the sine of 2x over 3 is equal to 1. So I'm going to look for where the sine of x equals 1. So looking at my paper, I have pi over 2. And that looks like that's the only thing I have is pi over 2. And so I'm going to say 2x over 3 equals pi over 2 plus normally 2k pi with k being an element of z. So solving that, I would have to multiply by the reciprocal 3 over 2. So I'm going to get 3 pi over 4. The 2's would cancel out, so plus 3k pi with k being an element of z. Now they don't want all of this on here. They want only the ones between 0 and 2 pi. So what you have to start doing is figuring out, okay, if k is 0, this is going to be gone. I just get the 3 pi over 4. If k is 1, I would take 3 pi over 4 plus 3 pi. Now if I add 3 pi to 3 pi over 4, I'm going to be out of this range. I'm going to be past the 2 pi because I'm adding 3 pi to it. So this is going to be my only solution that ends up being between 0 and 2 pi. And so in this case, I just have the one answer, 3 pi over 4. So if I look at number 5, same kind of thing here. If I solve this, I would say the cosine of 3x equals a positive 1. So I'm going to look up where the cosine of x equals 1. So cosine of x equals 1 at 0 and not till 2 pi. So again, we normally would combine that and say 0 plus 2k pi with k being an element of z. But this time we're going to say 3x is equal to that. So if I want to solve this for x, I'm going to multiply by 1/3, which is the reciprocal of your 3. So I'm going to times by 1/3. Well, 0 times 1/3 is 0, plus 1/3 times this would be 2k pi over 3, or 2/3 k pi, with k being an element of z. Now I want to find all the answers between 0 and 2 pi. So I'm going to start, if I put 0 in for k, this will be gone. I just get an answer of 0. If I put 1 in for k, I'm going to get 0 plus 2k pi over 3. Well, 2/3 is between 0 and 2 pi. So 2 pi over 3. When I put 2 in here, I'm just going to add another 2 pi over 3 because each time I'm adding 2 pi over 3. So now I'm going to add my 2 pi over 3. That's going to give me 4 pi over 3. 4 pi over 3 is still between 0 and 2 pi. So then I'm going to add another 2 pi to that, 2 pi over 3. So I would end up with 6 pi over 3. Well, if I'm at 6 pi over 3, that's exactly equal to 2 pi. And I don't want to have the equal 2 pi because I have that parenthesis instead of the bracket. And so I'm done. I found all of my angles between the 0 and 2 pi. So 0, 2 pi over 3, and 4 pi over 3 would all go in for your answers. So on this part, just think of it as starting with this. Ignore the k is there because the 0 is going to give you the first term. 1 will just give you that. And then each time you're adding another one of those on there. So I added 2 pi over 3. I added a second 2 pi over 3. I added a third 2 pi over 3. And I would keep going until my answer was larger than 2 pi. Let's try that again on number 6. So number 6, if I solve this, I'm doing cotangent of 3x over 2. That would equal a negative square root of 3. So I'm going to look for the cotangent of x equals negative square root of 3. So cotangent column, negative square root of 3 is at 5 pi over 6. If you keep looking down the list, I also have it at 11 pi over 6. But keep in mind, since it's a cotangent, the period should be pi. If I take 5/6 plus 1, I get 11/6. And so normally I'm just going to say 5 pi over 6 plus k pi, with k being an element of z because tangent and cotangent have a period of 180 degrees, or pi, each one. That's going to equal my 3x over 2. And so if I'm going to solve that, I'm going to multiply by 2/3. So, reducing 1 and 3 gives me 5 pi over 9, plus I still have to take the 2/3 there, so 2k pi over 3, with of course k being an element of z. So, if k is 0, I'm going to have 5 pi over 9. So I have 5 pi over 9. I'm going to add 2/3 pi. So if I add 2/3, since I'm in ninths, timesing by 3, I would have 5 pi over 9 plus 6 pi over 9. Same thing as 2/3. So that's going to give me 11 pi over 9. 11 pi over 9 is less than 2 pi. I'd have to get up to 18. So again, I'm going to have my 11 pi over 9, which was this answer. I'm going to add my 2 pi over 3, which I changed to 6 pi over 9. And if I add that together, I get 17 pi over 9. That's still less than 2 pi. 9 goes into 17, 1 and 8/9. I'm not quite to 2, right? If I take my 17 pi over 9 and add another 6 pi over 9, then I'm going to be too big. That's going to be more than 2 pi. So those are going to be my 3 answers that I ended up with, that end up being between the 0 and the 2 pi. So I had 5 pi over 9 plus 2/3 gave me 11 pi over 9, plus another 2/3 gave me 17 pi over 9, plus another 2/3 is too big. So I was done.